2, that means pi upon 8 into minus sign. Pi upon 8 into beta minus alpha. Pi upon 8 into beta minus alpha. This is the only answer. So this will be 0. Pi upon 2, pi upon 4, pi upon 8, beta minus alpha. Final answer equation. Okay, so this is the answer of question number 11. So now there is no need of converting it into back to x. As I have just told you that we have converted the theta into limits also into theta. This is the answer. Okay, now question number 12, let me talk about. Question number 12, let's see. Okay, now question number 12. With that, question number 12 here. This is x plus 1 out of multiplication. X plus 1, x plus 1 here upon x minus 1 under root. This is x plus 2 here dx. Now here we have got the linear fraction and the numerator and linear fraction. If I divide this separately, if I divide x plus 1 by x minus 1, then we get here x minus 1 minus sign plus 1. Okay, this will be plus 2 only. If I subtract, after subtraction we get 2 here. 2 is the remainder. What do we get here? We have converted this 1 is the quotient free from this, so it will be plus 2 upon x minus 1. Now it is still multiplied by 1 upon under root x plus 2 into ds. What do we get? This is 1 upon under root x plus 2 into 1. Then minus sign or plus sign 2 1 upon x minus 1 under root this is x plus 2. Okay, into dx. Now this is integrated as simple because if I substitute x plus 2 equal to t, okay, that means under root t or dx equal to dt upon under root t. That means only under root t will come out. Why? Because 1.2 twice it will be under root x plus 2. Why? Because under root t raised power minus half will be there, integration will be minus half plus 1, that is plus half, t raised power plus half is under root x plus 2 if I substitute t value. Okay, so this is the same value upon 1.2. This 2 here will come out because we will divide by minus half plus 1 in the denominator also after integration. So 1.22 will come out in the numerator. This is the integration of the 4. Now this is, let me integrate this. Now what we see here, if I substitute this t square, let me substitute here x plus 2 equal to t square. Then dx equal to 2t into dt. Okay, so this will be plus 2. Okay, this is 2t into dt because dx equal to this 2t into dt. 2 was already there. Okay, so in the denominator we have x. Now x equal to t square minus 2. This will be t square minus 3. Why? Because minus 1 is already there. If I substitute x equal to t square minus 2, t square minus 2 minus 1, that means t square minus 3. This value is t, or is the root of this. T cancels out. 2 cancel out. Okay, into dt. This is nothing but 2 under root x plus 2 we have obtained. And this is plus sign dt upon, let me write it as t square minus root 3 whole square. Okay, so this is x square minus a square type. It is in log twice 2 under root x plus 2. So it will be 1.2a. 2a is under root 3 into log of t minus root 3 upon t plus root 3 plus constant of integration. Finally we obtain x plus 2. If I substitute the value of this is 1.28, t value is now under root of x plus 2, which is log of in bracket under root of x plus 2 minus root 3 on under root of x plus 2 plus root 3 plus constant c. This is the answer here of question number 12. Question number 12 is done now. Okay, so this is question number 12. Now let's talk about question number 13. What is the question number 13 say now? Let's check. Now let's talk about question number 13. Okay, question number 13 is of what kind? Okay, so question number 13. Let me talk about. Okay, so question number 13 is sign of integration. This is question number 13. Again, this is 1 upon x plus b under root x plus a into dx. Now this is also of this type, but here under root x plus a have to remove. So this x plus a equal to that t square. Okay. For dx equal to, if I differentiate it with respect to t, dx upon dt equal to twice t into dt are taken from this, that's why this dx dt. Substituting here, we get this twice t into dt divided by x equal to t square minus a plus b. Okay, minus a plus b. That means if I take minus sign common, it will be a minus b here. Or if I take plus sign, then it will be b minus a. Okay, so in both ways we can do this into t. This is t only. T cancel out. Okay, so this value is, this is minus sign a minus b. Now let me take, this is 2 into sign of integration dt upon t square. Let me take minus sign only. This is a minus b under root of this whole square. Okay, so now it can be integrated easily. For the integration, 2 into 1.2a, a is under root a minus b into log of this t minus sign under root a minus b on t plus under root a minus b whole value. Now substituting value of t, finally this 2 cancel out. So this is 1.2 log x square minus a square type value. 1 upon x square minus a square is 1 upon log x minus a upon x plus a. This is nothing but 1 upon under root a minus b log of the bracket t. T is under root x plus a minus sign under root a minus b divided by under root x plus a plus under root a minus b plus constant of integration. This is the answer here. Okay, so this is question number 13 now. Question number 13 is done. Let me talk about question number 14 now. What the question number 14 say? Let me check. Okay, now question number 14, which we always, okay, we have described this previously also. Okay, almost all that. No problem. So question number now 14. 13 we have just done. This is sign of integration x plus a upon under root. Okay, it is x square plus b square into dx. Now we can directly write it down. Otherwise we can take this x plus a is equal to, so this is linear fraction. If I take x plus a is equal to, let me directly put x plus a is equal to a into, let me take two constant, a into vdx of this whole. Vdx of this will be only twice x. What I'm writing, this is vdx of x square plus b square. This is easily done, otherwise there is no need of this. This is nothing but a into twice x plus b only. This is x plus a. What do we compare? If we compare then coefficient of x, a is equal to only 1.2, b is equal to a here, yes, and b is equal to small a. Simple. So 1.2. So we can write it as sign of integration 1.2 value of is x into dx divided by under root x square plus b square plus b is a only on of integration 1 upon under root x square plus b square nothing else into dx. This could be done very easily by instruction only. There was no need of this whole, but I'm telling the method. I'm telling you the method. What is the method here? We substitute the numerator value equal to a into the dx of this under root value, the root value or what is called equation, plus b and the constant. Then we just find out value of constants a and b by just comparison of this. Okay, so this is this value. Now finally we can integrate this. Now this is nothing. And if I substitute this as t under root t, it will be 2x into dx dt upon under root t. It is directly integrated as 1.2. All this value will be under root t. T will come out in the numerator. That means under root x square plus b square will be upon 1.2. Because the power will be here t is power minus half. The integration will be minus half plus half upon plus half. Okay, so t is power plus half is this under root x square plus b square. This half of cancel out. Now this is again under root x square plus b square. This is nothing but sine hyperbolic inverse. This sine hyperbolic inverse x upon b. That's constancy. It is under root x square plus b square. A into sine hyperbolic inverse x upon b plus constancy. This is the answer. Question number 14th is done. This is the answer of question number 14. Okay. So question number 14. Now question number 15, let's talk about. Question number 15, what does it say? Which one? Again, this is of the same type. Talk about. Question number 15, sine of integration. This is dx upon x minus 1 under root. This is x plus 2 dx. This is question number this one. Alright, so 15 question. Now, again substituting that x plus 2, putting x plus 2 is equal to t square. That means dx equal to 2t into dt. 2t into dt. What we get here? This is sine of integration. 2t into dt divided by x value. X is t square minus 3 by t square. That is t square. X equal to t square minus 2, but minus 1 is obligatory, so it is minus 3 into t. T square minus root 3 whole square. It can be now integrated 2 into. Have we done this or? Okay, it was x plus 1. That was different one. Only a bit different from this one. This is x plus 1 in the numerator. Here it is x minus 1. And same denominator, but numerator is different. Okay. So for 12th and 15th questions are of similar type, but having some difference. Numerator difference is there. This is 2. Okay, this is 2 into 1.2 into a. This is under root 3 into log of this x square minus a square. It will be d minus under root 3 upon t plus under root 3. This is constant of integration. 2 to cancel out. This is 1.3 into log of t. T here is under root x plus 2 minus under root 3 by under root x plus 2 plus under root 3 plus under root 3. This constant c. Answer is this. This is question number 15th we have done. Now let me talk about next question. This is 16th one. Question number 16th. Let me talk about it. Question number 16th. Let me talk about question number 16th now. This is question number 16 now. What does it say? Okay, this is question number 16. 16 did this. Okay. So here we have obtained 1 upon x square plus 1 in a 1 bracket under root x here into dx. Now here there is under root x. Now if I substitute x equal to 1 upon t, okay, that will be, let me check, putting x equal to 1 upon t. So putting here x equal to 1 upon t, therefore dx equal to minus dt upon t square. Differentiating it with respect to t again is dx upon dt equal to minus 1 upon t square. If dt to that side, dx equal to minus dt. What about this x? Okay, it will be minus dt upon t square divided by this value will be 1 upon under root t, and under root t will come in numerator. No, if I substitute here x equal to t square, that will be better. I'm sorry, because here under root t is coming, that is not going to make the difference, but t raised power will come out. I'm sorry, here I have to substitute. Let me take that. We have to remove this square root value. If I substitute here x equal to, that's putting, I'm sorry, it could be easily done. Putting x equal to t square. Therefore dx equal to 2t into dt, nothing else. This is equal to 2t into dt divided by, now x is square equal to t4 into t4 plus 1. Okay. Now here, what do we get here? This is okay, 2t, now t it will be, because t square is x, 2t cancel out. It is nothing but 2 into dt upon 1 plus t4. Now if I, okay, change it into something different value. This is, let me take t square plus 1 whole square. If I write it as minus sign, okay, this will be 2t square. No change, because this whole square will be t4 plus 1 plus 2t square. 2t square comes out from this 3 plus sign. So we can write it as further dt upon is under root 2t, which will be t square plus under root 2t plus 1 in 1 bracket, a square minus b square. B square is under root 2t whole square, under root 2t. This will be t square plus 1 plus under root 2t, and t square minus root 2t plus 1 in 2 parts. Now it can be divided by and reduced into partial fractions, integral fractions. Let me find out partial fractions of this. Okay, that will be better than. Let me now find out this whole question. This whole equal. Now here x equal to t square we have substituted. The first substitution was there. Okay. So t value is there. Now let me finally change it into partial fractions. So reducing it into partial fractions, that this 2 is there, we will keep 2. The t square plus root 2 into 3 plus 1 into, this is t square minus root 2 into 3 plus 1. Let us take equal to at plus b upon, this is t square plus root 2 into t plus 1. This is plus ct plus d divided by t square minus root 2 into t plus 1. Okay, so let's check what are the equations coming from this. If I take it as 1 equal to, let me take 1 is equal to cross multiplying or multiplying both the sides of this by this denominator, we get at into t multiplied by t square, this is minus root 2 into t plus 1, b into t square minus root 2 into t plus 1, okay, plus c into t square plus t plus 1, because this root t square plus root 2 will come with this, and this will come with this. A simple question, plus d into t square plus root 2 into t plus 1. Let me make the equations now. Okay, so this is going to give us something. 2 is there, this 2 I have not taken. Okay, that was, let me find out value of constant here. That is 1 is equal to a into, this will be t cube minus root 2 into t square plus t, b as same value t square minus root 2 into t plus 1 plus c into t into t into inside plus root 2 into t square plus t into t square plus root 2 into t plus 1. Now comparing the coefficients here. On comparison coefficients of like powers. On comparison of coefficients of like powers of t, like powers of t, we get, what do we get here? Let me first compare t cube is 0 here, the left hand side equal to a plus c. First equation. From this imbalance a equal to minus a here, no problem. Now square coefficients. 0 equal to square is minus root 2 into a for a square. This is square only. This is plus root 2 into c, root 2 into c plus t. Alright. Now t coefficient of t 0. This is a, b, okay, minus root 2 into b, minus root 2 into b, and t is here c, and under root b, under root 2 into b only. Now constant coefficients. So 1 is equal to no constant in a, b is having a constant, b, c doesn't have constant value, d is having, so b plus d equal to 1, b plus c. Now from this, okay, so if I substitute here a equal to c, it will be, also this is c equal to minus a, it is minus under root 2a, minus under root 2a, minus under root 2a, it will be, let me write here this is second equation, sorry, let me again write the equation number, this is second, because first we have taken this, for the first equation, and the second, this is the third one, and this is the fourth one, this is the fifth one. Now what is the second equation implies, third equation implies, second implies a equal to minus c. Now from this, if I substitute a equal to minus c here in this case, it will be minus a, minus and minus added, which is implies that, let me write here, this implies that, this implies that minus 2 root 2 for twice it will be a plus b equal to 0. From this also, this is a minus a 0. This is minus under root 2b plus under root 2b equal to 0. This implies that. Okay, because a plus c equal to 0 from first one, a plus c 0. Now b plus d equal to this. If I multiply this by under root 2, the last question, it will be under root 2 is equal to under root 2b plus under root 2d. This, if I add, on addition we get this cancelled out. It will be 2 root 2d equal to under root 2. D is equal to 1.2 only, because root 2 will be cancelled out. 1.2, d is equal to 1.2. Now if I found out d equal to 1.2, so from this what we get, d is 1.2, so b will also be 1.2, 1 minus 1.2 is equal to b also, same value. Now from this also we would get under root 2b plus under root 2d. Sorry, this one. Minus under root 2b equal to d equal to b from this. Under root minus under root 2b plus under root 2d equal to 0. This question they show. That means b equal to d. So b equal to d, both are same values. Now b equal to d, if I substitute here, a equal to half, then a can be calculated. What is a? Minus 2 into a plus d is half equal to 0 from this equation. Therefore, d is equal to, it will be negative minus half upon 1.2. Okay, because here it is the equation. D is okay. Square, I think square we added. What is square here? Square. This was square AC. Sorry, square. B was of the sorry. Here square we were calculating. Here B was also there. Sorry. This is B here also plus B. This is not. I'm sorry, this equation is not proper one. Because here we compare t square. This was for here t cube. Now t square, if I compare, then it was 0. T square he was having, he was also having b. I didn't put, so this is b here. This is c here, d. All the 4 were there. Sorry. And b plus d is equal to 1. From this 1 is there. Okay, so this would be given as plus 1, plus half, or it could be 1 here. 1 can be taken to this, so under root 2, answer under root 8 plus under root 2 c equal to minus 1, but under root 2 c, c is minus a, so minus 2 under root a equal to minus 1, a is equal to 1 upon 2, c is negative, a is equal to 1 upon 2 positive, and c is equal to minus 1 upon 2. So finally, all the 4 constants are calculated. Sorry. So finally, we have obtained the answers of these 3 questions. What are the answers of these questions? I mean, reduced form, fastest form, fastest fraction. But this is twice into this. So, what is a here? Therefore, this integration will be 2 into value of a. Value of a is this, so 1 from root 2 is 1. So 2 I hadn't taken. 2 into a is 1 from root 2 only. It will be 1 from root 2. Positive value a. And okay, this is a is x, sorry, t here, under root 2 into t, plus b. B is here, 1.2 plus 1.2 divided by, it was t square, okay, minus root 2, like take minus root 2, so minus root 2 into t, or plus root 2 into t. Okay, it was I think plus root 2 into t. It was a is for t square minus root 2, it means plus root 2. It was plus root 2 into t plus 1. So plus 1 I have taken below this, and this is dt. Okay, and then b ct plus d. What is c? C is minus 1. It is 1 point under 2. You multiply 2, so it will be only 1 point root 2. 1 point root 2. If I write here plus sign, and take the sign of integration, minus 1 point root 2 into t plus d is 1.2 divided by t square minus root 2 into t plus 1 into dt. This was the past fraction. Value of ct plus d is at plus b. B is 1.2 as d. B and d same. C and a was same but negative sign. And with multiply by 2 here, 2 into 2 or 1.2 was cancelled out. From this also, I think will be cancelled out. Because this is also to multiply by 2. I'm sorry. So a was here. This is only 1. I'm Well, this is also 1. Because we have to multiply by 2 to both the constants here. This 2 are there. 2 we have to multiply by to both the a and b, c and d. Now in a we have multiplied, it was 1.2 root 2 to get it out, 1.2 is there. And in case of d, c also it was 1.2 root negative to get it out. But here a, b and d and b was 1.2, so only 1. Now it's okay. Now let me integrate this one. So this can be now converted into 2 parts. Now if I write here the first part, because this is under root 2 and this is twice t. If I write it twice t under root 2, let me take 1 common. Okay, because this is twice t and under root 2 is there. So first we have to convert this into 2 parts. Okay, so or if I keep it in the same way as this under root t plus 1 equal to a into again constant coefficient and ddx of this plus b in 2 parts will be divided and a and t is done. Now let me do it with inspection. What is inspection here? That we have to get 2t plus under root t, under root 2t plus under root t. If I multiply this by 2 and divide by 2, no change, it is 2t. Now 1 for root 2 I have taken common. Okay, and this plus 1 I'll multiply later. Okay, so it will be 1 for root 2, but this 1. Let me add here under root 2 and subtract under root 2. So it will be there and plus this 1 is there. Okay, this plus 1, because I have taken this plus 1 is also there. These two will be separated, but this first one will be t square plus root 2 t plus 1. Okay, this is divided into 2 parts. Again, this is also written as this 2t minus root 2. Okay, so let me take minus sign common here. And minus 1 common root 2 again. It will be 2t. Minus root 2 I have to put and plus root 2. And this 1 is already there plus 1. So this divided by whole t square minus root 2 into t plus 1 into dt. So also dt. Now let me divide them into 2 parts. The first partition will be 1.2 root sin of